Here we go. Oh. What's up? I'm Austin. I'm here with Etta and Carlos. We're on day 2 of week 2. We're in the midst of the scripts. We're scripting lots of stuff, and we're learning about providers and signers and dealing with mnemonic files and loading those up into scripts and scripting your even contract interactions. Today is about scripting interactions with smart contracts, and we're going to learn that like everything is a transaction. Like it's all about just like that call data, right? If you want to talk to a contract, it's not like you're going out and poking an app. You're crafting a transaction and you're sending that transaction, and that transaction ends up poking the contract when it gets mined into the block. So here we go, Carlos. So I want to get my stack going locally so I can follow along with you. But I think, yeah, you kick us off and tell us how to get started, and I'll follow along on my machine too and jump in.
Okay.
I'm gonna follow along too. I'm here.
All right.
Too.
Yeah, I'm learning a lot from this scripting
we might switch at some point
okay.
the call.
Yeah, sounds good. Sounds good.
Okay, let me share. Okay.
All right.
Can you see?
We've got the sea meeting the
okay.
land, and we've got Sanford and Vitalik's balance.
Firefox. Okay, perfect. Okay, so this is what we have so far from yesterday. We created like this providers file and wallets file where we did like some, like some calls and some testing. The only thing that I did off camera was like putting these files into the day 1 folder, because we are going to create like day 2 folder today. So that's the only thing that I did. And also I did git init. So I initialized a git project and did like a commit with the stuff that we had. I just did like git commit.
Is that pushed up live? Could we grab that too, or is it's not live? Okay, cool.
It's not,
cool,
but
cool.
I mean, we can create
it will be for you watching at home.
Yes.
Like the person watching at home will be able to easily fork this stuff, but we're gonna have to do it live as we go and try to follow along with you, which is cool.
If not, we can create, mid call. We can just create a repo and push this to it, and then we can switch, and someone can just pull my code and keep going. So we'll see how it goes. Okay. So I think a good way to start might be to do a bit of a recap from what we did yesterday. And I was thinking, like, we are going to use these providers, wallets, and signers like all the way like this week, so much. So maybe we can create like some kind of utils file where we set up all the provider and signer and wallets stuff, and we will just import that from other scripts, right? So it's going to be easy. So we don't need to instantiate the wallet like every time that we need to use it, right? So
basically, I have like 30 projects on my local machine, and all 30 projects basically have a local mnemonic file that I've generated just for that project. It loads that local mnemonic into a wallet. I send some money to it, and then I code up some interaction, right? And so you're saying, let's have that as a utility file, so it just like does all that stuff for us, and we can get started writing the guts and the important stuff, the contract interactions we want to use.
Yep.
Awesome.
Yep. Okay, so let's create first like the day 2 folder, and let's create the utils.js file. Okay. So I think let's import Ethers.
I have to bring in Ethers, I bet. Yeah. Every script starts with importing Ethers. Got it.
Okay, so the first thing that we saw yesterday was providers, right? So let's create get provider function. Let's see what we did yesterday. Okay, so here we have the Infura. On wallets, I think we also, remember that we did like, we were instantiating 2 providers, like Mainnet and Rinkeby, because we had this issue that we were trying to use the Rinkeby provider to get the ENS and it wasn't working. So yeah, let's see. What if we, on these utils, let's have this a Mainnet flag here, default to false. So we can request the provider and say get provider. And if you leave the default, it will get the Rinkeby provider. usually when I set the default for a function, I usually try to do like the least like destructive way, you know. So if you get a provider, if you don't say anything, it's going to get like the Rinkeby provider. And if you want to get the mainnet, you will say get provider true, you know, so that will get you the mainnet provider. So this should be something like provider URL. And if mainnet, we're going to use this like ternary operator. Okay, if it's mainnet, we are going to use this. No, sorry. And if not, we're going to use the Rinkeby one. Okay, and now we are going to return a new, this was Ethers providers, yes. Okay. Does this make sense to you? What do you think? Yeah?
Yep,
so,
looks good.
So the idea here is just to do, let's test this function. So we can do.
Just get the block number or something, right? Just make sure we're talking to it. Yep.
So this would be provider. And we can do this. I think it was provider get network. Yeah. Okay. So if we run it, day 2. Oh, let's. Okay. Okay. This was happening yesterday. Remember that we always forget to import the like the .env config. So if you don't do that, I mean, if
gotta
you
get that .env.
Yes, because if not, this is going to be null, and it's not going to work. Okay.
And if you don't bring in the .env, just real quick, if you're not using an environment file, you're probably copy pasting mnemonics or private keys right into your code. And that's a really, really easy way to get it accidentally published to GitHub. Even having it as an env file is a little scary, and you should only have like either testnet ETH, or this is an actual mainnet script, so it has mainnet ETH and it's in like a very special place. But like that .env file, if it gets committed to GitHub, your money's all gone. So you have to be very careful to have it in an env file and have that env file get ignored. And it's almost like that's the first thing you should do before you do anything. Bring in the env file and ignore the env file, and then make sure you're solid. Do not commit that thing to GitHub or you will get wrecked.
Yes. Yeah. If you remember from yesterday, we created this git ignore file, and we are ignoring the node modules and also the .env file. So let's see why it's not working. Okay. Why is this happening?
I think it's up above. The git, like the day 2 file is inside of that directory, but the env file is one directory above.
Okay, but I thought that it was like getting like the.
It doesn't do that.
I don't know.
Because you're in the day 2. I bet if you copy paste that env file into your day 2.
I think it's not the file, but it's that I'm in the day 2 folder.
It's where you are. Yeah.
So I think if I run it from here, I think it's going to work.
Yep.
Utils. Well, I'm not going to print the infuriate.
No.
Okay, let's see now. Boom, you got it. Okay.
Okay, cool.
So I just like printed the get network. And if I pass, this is on Rinkeby and chain ID is number 4. So if I say true, so it's mainnet equals to true, I should get the Homestead. Yes, chain ID 1, Homestead. Okay, so this is working. Cool. So what we did yesterday after providers was creating a new wallet, right? So let's have the generate wallet in a new wallet function. Then let's copy. I think this should be fine. So do you remember this? That we were
Just
like
create random, dot create random on Ethers.
Yes.
Yep. Yep.
And
And
here
honestly, you could generate your own private key, right? If you want to come up with your own 64 character hexadecimal private key, and as long as it's really good and random, you could do that too. But I bet Rickmu does some special stuff with create random where he's using a lot of weird randomness just to be safe.
Yes. So yeah, like we could like store this on a file, on txt file or whatever. But for now, we are just like going to print this on the console. So let's see now. Okay, so maybe we can use like this private key today, like a new for our. So
let's do it where it like generates the private key but doesn't expose the private key to the screen. So
Okay.
let's do it where you're actually going to create a brand new account and we'll fund it, but we shouldn't expose it to the camera if we do it correctly. Just to go through those motions because it's a good exercise.
Okay, so what do you want, like doing like this?
We'll just comment out the private key in mnemonic, and then let's write the mnemonic to a file, right? That's what would be in the .env file.
Yes.
Is that right? Is that how we would do it? So you want to generate one, but you want to like, can you write to the env file? That's probably not part of the .env stuff. You probably just need to copy and paste it. Yeah. So you'll generate it and then off screen copy paste it into the env file. Is that how we're going to do it?
Yeah, I'm going to do that.
Kind of weird. Sorry, it's a weird like.
No, I think it's a good exercise because
a good exercise.
Because it's not good to share this stuff while you are like broadcasting to people.
Yeah.
So let's do that. I'm going to paste. Okay. Going to have this private key.
Hiding a private key. All right.
Wait a minute.
It didn't come up. No worries. Didn't see anything.
Okay. You're good. Okay. So this is my address, like the new address. So we can find this address. And if you remember on this env example file, we have my wallet private key. So I just copy paste my new generated private key here on my env file, right? So
cool.
Actually, I'm going to, if you remember, we imported like a new, some music, please.
I always do that now. It's so funny. Running distraction when someone types in their password.
So let's import, oops. Oh, what's that? Okay, so let's import this one. So it's like these three.
There we go. Okay. And we haven't exposed that private key yet, right? Like that's a good one. Okay, cool.
So D3. Okay, so this is the one. Nice. Okay. So this is working. Okay, so the last thing that we want to do in this utils file is creating a get signer function. We are going to do the same thing, the mainnet flag.
It's get singer, which is also like, singer. I don't know, how good of a voice do you have?
Sorry.
That's good.
My spelling is so bad. Okay, so here, since we have if you remember, we have for the signer, we need like a provider, right? And we needed our private key and also the provider, right? So let's copy this stuff. And okay, so this is already populated because I just like populate this env variable, but we need the provider. So what we can do is get the provider from the function that we just created and pass along this flag. And then this will be provider. Make sense?
Yes.
I think we can remove this. So let's return. Yeah. So we can signer, get signer, and then what can we do with the with a signer, like get balance or get address maybe. Yeah. Okay, so let's see if this works.
There. Yeah.
Yeah, like the
Awesome.
V3, right? It's the same that we had on our wallet. Okay.
So when we get the signer, it connects to the mainnet provider. Is that what's going on right now? Oh, depending on.
Yes. So the default is connecting to
Okay.
Rinkeby. But if you want to connect to mainnet,
you put true in there, and then you've got a mainnet signer. Okay, cool.
And the good thing is that we can do this. So we can have, like we did yesterday, we can have a provider connected to mainnet and a signer connected to Rinkeby. So we can use the provider to get in like some like ENS data, for example, and our signer to make a transaction in Rinkeby.
Awesome.
Which is great. Okay.
Yep. It's really good to show that distinction between what a signer and a provider is and how those two things are kind of mutually exclusive, but you can connect at any time. You can connect your signer to different providers and have that like wallet basically signing transactions on those different networks. And it's all the same. It's all the same, like it's all EVM compatible. So it's going to be the same across all these networks, whether it's a testnet or an L2 or Ethereum. There's just like a little chain ID difference between one network and the next. And speed. I mean, there's a lot of differences in consensus and stuff, but from our point of view, it all works the same.
Yep.
So I had a question at this point. I always think of the signer like the authentication piece. I don't know if that's the correct way to like express it, but like it's what like you, like your address, you sign the transactions with your address, you can tell who it is. So that's like an easy way for me to like distinguish provider and signer.
Yep.
Yeah, signer is like your private key that you've generated, right? And it can take that private key and sign things with it, but it's really like very isolated, right? And the provider is like your connection to some network. And so you want to connect to a network to get information, do some signing over here, and then ship it off to that network to send it to get it mined. I think that's a good way to think about it.
Yep. Okay, so if we want to use these functions in other scripts, what we need to do is to export this function so we can import it from other scripts. So to do that, remember that we are using ES6 module syntax. So this is the way to import it, to export it. It's just like export and an object, and we can have all of our functions here. And
we had to add the module thing to the package JSON. That's what unlocked this stuff.
Yes.
Right there.
You have to do that, or you can also name the file MGS with the extension MGS if you want. But if you want to enable for the whole project, it's better just to write this line here. Okay. So this will be ready. What if we, at the end of yesterday, we send it a transaction, right? We send like some ETH from our address to Sanford, remember? So let's do the same thing, but using the utils that we just created. So I'm going to create a new file called send ETH.
Could you drop the utils file to us so we could just copy paste it while we're doing this live, so we don't have to code
that would
it
be really helpful.
I wrote like half of it, but I didn't get it all, like specifically like the Infura endpoint I didn't get typed up correctly. But if you could just YOLO it to the chat somewhere where we could grab it, just so we have a live version of it.
Sent.
Dope. Thanks, dude. Okay. LFG.
Let's go. Okay, so now on the send ETH script, let's paste what we did yesterday. Okay. So if you remember, what we did is just getting the Sanford address from their ENS, and then with our signer, send the transaction with our balance. Actually, I didn't copy, our balance here.
Balance divided by 10, like 10% of the balance, right?
Yes.
Yeah.
10%, yes. Okay, so you see Rinkeby provider. So now the good thing is that we can do Rinkeby provider, and this is going to be get provider
Oh, well, it just like magically imported that for you. How did you do
Yes.
that?
I don't know. My ID, I think.
Your
just,
IDE has something neat. Oh man, I'm jealous.
Yeah. So now we also need a signer, right? So we can do a Rinkeby. Well, we want this to be the mainnet provider, right? And we want a mainnet provider and a Rinkeby signer. Get signer. Okay. So my balance, I think this should be signer, no, Rinkeby signer.
And do we need to await the get provider and get signer, or is there no async await happening there?
Yeah, I think that there is no need.
Okay.
Because actually when you create a provider, it actually
there's no async. There's
yeah.
no callback. Yeah, okay,
Yeah.
looks good.
I think okay, yes. My balance and for mainnet provider. Okay, sending it to Sanford, and this is going to be Rinkeby signer, my balance. Okay, so I think like we will need to fund this address, right? Because we don't have any Rinkeby on it. So let's do that.
And that's like to pay for the first gas fee to send, and obviously the Rinkeby to send as well.
Yes. So let's grab this address and search for Rinkeby.
And just like kind of a disclaimer here, be careful about creating mnemonics in your file system and then having an address or a private key that you paste into MetaMask, because now you've got this account that lives in MetaMask and this like private key that's on your system, and if somehow that leaked, you didn't know it, and then your MetaMask has it, just be careful. You almost want to have a developer MetaMask where you're only putting in private keys into this MetaMask that like clearly is not like for production stuff. just a disclaimer. We kind of copy pasted private keys around a little bit there, and it's a little bit scary and messy to have that in MetaMask, although it like lets us do a lot of neat things like he's doing, where he's like getting his address out of MetaMask and probably using it to send stuff if he needs to.
Yeah, I mean, this is all like test accounts. That's probably why I'm so wild with it. Be careful. So can any of you like send me some
here?
Because this faucet
paste me that. I can send it. If you paste me that address into our chat, I can send you some. And yeah, so if you're at home and you're having a problem with one Rinkeby faucet, go Google Rinkeby faucet. There's probably a bunch more. But since we're kind of in a hurry here, I'll send just some from my Rinkeby stash. But getting testnet stuff is just kind of a challenge in the first place, just because you have, a network that's like Ethereum, but not nearly as secure as Ethereum, right? So these test nets can get attacked and fall over and just have issues. So sometimes these faucets go down because they get attacked also. Okay, I'm sending you some. Oh man, my MetaMask is so slow. I'm sending as soon as MetaMask starts responding. Here we go.
So let's.
Okay, it is incoming. So 15 seconds. It should be there.
Okay. So in the meantime, let's.
I sent 0.5.
Thank you. So let's bring this.
I have 800 of them.
Okay. So let's utils. No, what I'm doing wrong. Oh.
What are we trying to get? Oh, you want to. Oh yeah, you didn't bring in ethers. So, and remember, it's format ether is what we're going for, right? Utils.format. Okay, we got to be careful. There's two different utils now, right? We've got utils as in our file, and then utils as in this like selector within
inside.
ethers.
Yes.
Like those things are not related. Yeah. Okay.
So I'm going to return here because I only want to check first if I have the balance. So let's see. And the two send this. Why? Okay, so let's exit. How was it in Node? It's like process.exits, right? Something like that.
env, yeah, something like that. Yeah, that's it. Yeah.
Okay. So can you see like my balance is
yes.
Okay, cool. So Now let's check if we got the Sanford address correctly. Remember that we are using the mainnet provider to do the lookup of the Sanford stout ETH. So let's check my balance. Yes, and the Sanford address is resolved here. Nice. So the last thing is just to make the transaction, right? So we are going to use Rinkeby. So that's why I'm using the Rinkeby signer here and the send transaction command. And I'm going to send to the Sanford address, and the value is going to be my balance, like the 10% of my balance, right? And remember that when this is completed, like after this await, this means that the transaction has been sent to the mempool. And we actually, I think, Austin, I remember you telling me that the hash is deterministic, right? Like whenever you create like a new contract or create a new transaction, like the transaction hash is always deterministic, right? So you can, because of the nonce, that you can like derive always the hash, even if the transaction hasn't been mined yet, right?
Going back to the idea of like an air-gapped laptop, you can actually, craft the entire transaction and sign it, and you'll know the transaction hash that will go into the mempool eventually without ever even broadcasting it. Yep.
Okay.
But at that point, I think it's coming back to us and it's already in the mempool, right? Line 20 is blocking on, it's not even blocked on. Line 15 is blocked on, does this thing get to the mempool? And then line 22 is blocked on, did that thing get mined into the chain? Yeah.
Yep.
Cool.
So should we go for it?
Go for it. Yes.
Okay. Send ETH. Let's see.
So it's
our balance, Sanford address, and we have the hash
now it's
here.
getting mined. Yep.
Yes.
So it's in the mempool. So now this is the 15-second block time. We're waiting on Rinkeby.
And we can just like copy and paste this hash into Etherscan, right? And then
it'd be rinkeby.etherscan.
Yes. And then I can paste here the hash. Oh, it's already succeeded. So let's see here. Yeah, mined.
Transaction mined.
And
so can we look at this? So it's from our account, our D37 account, and that's the mnemonic that you just created locally. And it's going to 8A94, and that's Sanford. Okay.
Yep.
And then
we say like the 10%, right?
Yep. Cool.
So it worked.
And if you hit up and enter again, it's going to do the same thing, and it's going to be 10% of its balance, but it's going to be less now, right? It'll be like 0.49 or something like that. Yeah.
49.
Cool.
Okay, so let's copy this one.
And this is the cool thing. It's like programmable money, right? Like now it's scripted and it will do what it's supposed to do over and over again. So this little script could just sit here and run and do what it needs to do. Very cool.
And you can like listen to events and run this code whenever you want, or you can like set up a cron and run this like every hour. It's up to you. So that's the good thing about like interacting with smart contracts and the Ethereum blockchain with the scripts, right? Instead of like doing manually as we were doing like the first week, this is all programmable and dynamic, which is great.
Awesome stuff.
Okay.
I just got, so mine didn't have things installed. I had to do the npm install .environment, npm install ethers. Then I had to edit the package JSON to add the module type. And now it's all working. So I've got the same utils going on over here. Is it time to talk to some smart contracts? Is that what's next? We're sending ETH. Sure, we're sending ETH. That's easy. Let's make some real transactions now.
Yes. Let's do that. Okay. So I was thinking first, let's read something from a contract, right? So first we can read something, and then we can like write or send like a write transaction to a contract. So I was thinking that maybe we can use the Sanford Stout NFT that we created last week, so we can like do some testing there. So let's create a new file. This is going to be the H2, and let's call it like contract read.js. Okay.
And we'll bring in ethers, and we'll bring in
our
utils file.
Like always, yes. the first thing is always like importing Ethers. Yeah. From Ethers. Okay. So now I wanted to show the like the Ethers documentation for the contract instance. So this is yes. So if you want to, I mean, there are like a few ways to interact with a contract, but this is like the quickest way to go about it. Like creating a contract instance in Ethers, and then you will have like all the utils for that contract, and you can call the functions directly. But I think maybe it would be nice to show, maybe when we do like the write transaction, like showing how to interact with the contract without this, and just like with the raw send transaction and the Calldata.
I think that if we do a contract interaction and we get onto Etherscan and we see it, we're going to see like, oh, wait, like interacting with a contract is just a transaction. And how does it know how to do it? It's this Calldata, and we'll look through the Calldata. Yeah, sorry, I didn't mean to interrupt. I think that that's the way to go, though. Yeah. Okay. We want to see that eventually. Right now, it's like, what the heck is this ABI, and how does that work? Yeah.
Because if we copy and paste this, okay. So I think we know most of this stuff, right? I mean, we know what a contract address is, and we know what a signer or provider is, right? But we don't know what an ABI is for now. So let's start with the address, right? Let's call it like Sanford NFT address, right? And then we have this Sanford NFT ABI that we don't know what that is yet. And then,
but you're gonna learn.
Yes. And then signer or provider, like any idea why we do want to use like a signer or a provider here? Do you know what will be the difference?
I would say that if you were on like an air-gapped machine and you wanted to sign a transaction going to the contract, but not send it through the provider, or if you were just reading, that would be, you could use a signer. But if you're just reading something, you could technically just put in a provider here, and it's basically a read-only connection to that. So it's like a signer could be a write-only connection to the contract, where you're writing a contract and setting it up off-chain and then putting it in somewhere else, or a read-only connection, you're just reading balances and stuff like that. Or you could have a signer that's connected to a provider and put that in, and then it's basically a write connection to that contract. I think that's the way it is, but it's like maybe.
Yeah, no, I think so.
Is that right? Yeah.
Yeah, I think so. So in this case, this is called contract read. So we are going only to read data. So we are going to use a provider. So it's going to be Rinkeby, because we like the Sanford NFT is deployed on Rinkeby. So Rinkeby provider, and this is going to be just get provider. By default is Rinkeby, and this will be here. Okay. So now what we need is to find the Sanford NFT address. And this happens to me like all the time. Like I always, where is the contract, right? Because I deployed it and I forgot about it. So sometimes I have to search in Etherscan where the contract is. So if you remember, like last week, Sanford bought some NFTs, right, from this contract. So what I will do is go to Sanford Stout.
About to do some blockchain detective stuff is what this is all about, right?
Yes,
we know that there's this one account that interacted with it, so we're going to go to the account and then look through their transactions and see if we can find this address. Is that what we're doing?
Yeah, because I think this is important to show, because I'm always doing this, you know. So I forgot. Oh, what is it? Yep. So I'm going to go to the Sanford address, but this is mainnet, right? So we can click on the B here and go to Rinkeby. So this is the Sanford Rinkeby account. And you can see here that the NFT that they minted last week. And if we check like the history, we'll check that owner mint. This is the function that we called. So we can just click on the transaction and we will see that we interacted with this contract. So
we found it.
Yeah, we found it. So here's the contract. And here's the contract, and here's the address that you can just copy here from the URL, or maybe just like here. So we got it. So we are going to paste the address here.
So we know what contract we want to interact with, but now is the real heart of this whole ABI learning experience, right? We need to know what functions we can call on the contract and what arguments go with those functions. And that's where this ABI is going to come in. It's going to tell us how we can interact with the contract.
Yes, yeah, I think it's actually an interface just transforming like data to bytecode, right? Because the EVM only understands bytecode, right? The only way to interact with the EVM is with bytecode. So we don't, I mean, we will see later that we can provide the Calldata, like the actual like hex digits. But I think in this case, it's easier to go with the ABI. And when you have a contract verified on chain, like this one, you can find the ABI down here. After all the code, you can find the ABI here.
So just to double down on that, if someone deploys a contract and you go to Etherscan and you look at it, all you're going to see is bytecode. You're going to see this mess of hexadecimal characters that says this is what the contract is, and that's really hard because it's compiled bytecode, right? So what happens is someone will verify their contract. They'll say, hey, for this given bytecode, here is the source code that you can compile to get the bytecode. And then Etherscan puts the source code and the ABI up for us to make it available here. So once someone verifies the contract on Etherscan, anybody else can get in and snag that ABI or look through the contract code. And really, if you take all that contract code and you compile it exactly like they did, you'll get exactly the same bytecode and exactly the same ABI. Etherscan just hosts it up, and it makes it really nice for us because we can just get in here and copy paste it into our scripts and stuff, yes, as long as someone verifies it.
Yes. Okay. So let's. I mean, you can, for example, let's say that we want to read the mint price from the contract, right? So it's here. So we could just go to the ABI and copy only the mint price definition. So we could only like copy this part if we wanted.
Oh wow. Okay. Yeah.
So I don't know, maybe let's copy the whole file, right?
Yeah,
so
I think so. It's just cleaner to just copy the whole file.
Yeah. So I'm just going to copy this, and I'm going to create a folder.
I think that's a way to go. Yep. Because this file is going to be big, right? It would be nice to have this ABI stored somewhere where we can load it dynamically, and it wouldn't mess up messy up our script.
So it is Sanford NFT ABI, right? Okay. So we want to export this also. So let's do something like a const ABI and just paste this code. And
there it is.
You know, I have like this prettier plugin on my IDE. So whenever I save it, it's going to format it for me, which is nice. You know, so you can see like the whole. So it's basically like the type definition of every function that you have on your contract. And since we imported, because our contract is actually really small, right? We don't have so much stuff there. It's just like like a couple of constant and a couple of functions. That's it. The thing is that we are like importing or inheriting some stuff. Yeah, inheriting some stuff. So all the stuff that you are seeing on the ABI is also from there. Like for example, like what is like owner? No, not owner. Like the balance or owner. What is the?
Yeah, like the balance of, or even like there's like an tokens of owner. There's like a bunch of functions that come in with the ERC 721 standard.
Yes, and if you see here, for example, the balance of function, which is from the ERC 721, I think, you have the inputs of that function, the name of that function, and the output of that function, right? So with this ABI, Ethers know how to interact with your contract. So in our case,
it's kind of like an API, right?
Yes.
It's not an API like a server, but it's more like if someone like Swagger, I remember back in the day, you would take an API and you would export it, and then you would have all these nice docs about how to call your backend service, right? This is like a definition that tells you how to call different functions on it. It's like, here's the API for the contract, but it's called an ABI, and yeah, just think of it like an API though, or like think of it like an API definition. Like here are all the functions you can call, and here are the arguments you call with each of those functions.
Yep. So let's import this from here. We can do just like import Sanford NFT ABI from, this would be ABI/Sanford. Okay, so now we have the ABI and we can just like paste it here, right? So
Nice.
now we should have the contract interface or the contract instance on Ethers. And when you have that, you have, remember, like the address, the ABI, and the provider. So we can start making calls, like in this case, only read calls, right? Because we are using a provider, not a signer. So let's, for example, check the mint price.
I think you might need to pull out line 6 too.
Oh, yeah. Thank you.
Nice.
Yeah. So let's do, this would be like Sanford contract, and we want to call mint price, right? So we could Sanford. Okay, no, SS doesn't work. Sanford. So, yeah, I was like Sanford Stout, but no, SS is not a good mint price. And then we can remember that this is going to come as a big number, right?
Let's paste it. Let's just output it though, and let's run into that problem. Okay, let's print out the mint price. Let's see what happens. We should get a weird number, right? And your Web3 brain should know you're going to get some kind of weird big number here, but let's print it out and see it.
Let's see if it works. No. Export. Okay. Export. So I think we forgot to export it, right?
Yeah.
So let's do export default ABI. Boom.
There it is. Big number.
Yes.
So you at home, if you have a big number, how do you format that into a readable format? Is it format?
Give it a go. Yeah, I think we talked about format ethers, and then you could also there was some other thing like big number dots.
There was like a 2 number. You could do .2 number, but then it's going to be it's not going to be actually if it's in ether, then it's going to be times 10 to the 18, right? I think this is the right way to do it.
Yes.
And it's almost like sometimes you just kind of trial and error, like let's try format ether and see what it looks like.
Nice.
There we go. So it costs 0.01 ETH to mint one of these NFTs.
Yep.
Awesome.
Okay. So now that we read the price, what if we copy and paste, like create a new script called contract write, and with that price we try, because this is only like a read operation. This is free. This is not a transaction. This is just like reading. But what if we try to mint an NFT from the code, from the script? What do you think? I think it's a good
next for sure
step, right?
Yeah, I say we duplicate this, we make a contract write, and we put a transaction out there. There's I feel like we're quickly going through some of this weird ABI and Calldata stuff that we'll want to dive into and really see. Maybe we create a write script and we write to this contract, and then maybe we hand it over to Eda, and Eda makes a little DAI contract, like read the balance of DAI and send some DAI around or something, and then we can explore some Calldata too.
Yeah, I think maybe after this week we can create a new repo, and I can push this to the repo, and then like Eda can pull that out and start from the with all the codes that we already have.
Cool.
Okay.
I'm following along the live coding. It's
cool. Okay, so we are on the contract write script. So this is going to be the same, right? But instead of having like the Rinkeby provider, we are going to need like the Rinkeby signer, right? Because we want to sign a transaction. So, and we can't do that only with the provider. We need a signer connected to a provider. And this is what is our get signer function does, right? So we don't need this. We can have the signer here. And then this is going to be the same, right? It's like the instantiation of the contract is going to be the same. And we have the price here. And then we can do the same thing, but instead of calling like mint price, we are going to call, we are going to create like this mint transaction, and we are going to call some for contract dot, I think mint, right? Mint will be the name of the, let's double check.
Yeah, I'd need to look at the contract, or we'd need to see the code.
Yes.
Yeah, it's mint. Yep.
Mint.
And we could see that probably also in the ABI if we wanted to search it too. But I think like looking right there at the contract does it.
But here you will have the mint price and the mint function that, as you see, doesn't take any inputs, and also is payable, which is going to be interesting, right?
I don't think we can see the payable thing that you're showing.
Oh, okay. Sorry. Yeah, we're on the screen. This one. Okay.
There we go. There we go.
Yep. Here, yes. So you can see the inputs are empty because the mint function doesn't take any arguments. It's just the mint function, and then it's payable, right? So that's going to be interesting because let's see what happens if we call the mint like directly, like this. Let's see what happens.
Yeah.
Yes.
Yep.
Okay. And yeah, let's console. Let's do some console log here, like minting NFT. Then send the hash, and then, oops, let's await for the transaction to be mined. Let's wait. Okay, what do you think?
Well, it's not going to work because we're not paying anything, but let's see what it does. Let's get the error.
Yeah.
We know we have to pay for this NFT. We're trying to mint it for free.
Let's see what happens.
Yeah.
Okay. The mint price is this, and I think we got like an error, something. Yeah, I think this is good that we get this error because
this is what errors look like in Web3.
Yeah, and this is
99% of this information is useless.
Yes, like this is very usual, right? To get like this unpredictable gas limit, that is like a generic error. So, but if you look here, the reason is like the insufficient ETH amount. Actually, if you check the code here, I don't know if this is big enough, but in this mint function, you see that we have a require here, and if this isn't true, it's going to revert the transaction with this message, and that's actually what we are getting in our transaction, right? Like execute reverted insufficient ETH amount. And that
we should talk about value for a second, as we're going to get into Calldata. So everything's a transaction, and a transaction is just an object, and there's a to and a from, and there's a value there. And that value is like the amount of value that's coming along with it. You'll pay some gas to have that thing get mined, but value would be actual ETH moving along with the transaction from the from address to the to address. And then there's a data field, and we'll get into that in a second. But just knowing like the anatomy of a transaction, there's the to, the from, and the value is actual money getting sent along with it.
Yeah, as you can see here, sorry, Ella.
No, I was just going to say like Payable functions were like new to me when I was starting as well, because you can directly like natively have that send payments. So like it doesn't seem like it accepts an input, but like because it needs like the native payments layer over there to transfer some ETH to actually mint the NFT.
Yep.
Which also goes into how like functions are safe at first. And if you try to call a function on a contract that isn't payable and send in some value, it's going to revert. It's going to be like, yo, no money, no money. So like you have to mark your functions as payable, and this payable modifier is something that's obvious to everyone. It's like, oh, like money needs to go in here, and we're not sending any money.
Where is this money stored? Where is this ETH stored? If I send some ETH to the contract, where is that ETH going?
In the contract. The contract has its own address. Yeah, this is a kind of an aha moment too. It's like we have these EOAs, these externally owned accounts, and we're generating them with these seed phrases. But whenever we deploy a contract, it has an address too, and it becomes a player in this massive multiplayer game, and the contract can send and receive ETH or tokens or anything else, just like an EOA or an externally owned account can.
And I think that is why it's important to not forget to do a function like this, right?
Yes.
Oh, yeah.
Because imagine that if you forget to do like a withdraw function, that people will mint your NFT, they will send ETH to your contract, and then your ETH, well, your contract, it will be there like forever,
Stuck
right?
forever.
Yep. So don't forget to have like the withdraw function or something similar. So you can, so where you can move funds from the contract to your account or to other accounts or whatever.
And we'll get into smart contract building eventually. You'll learn all this stuff next week.
Yes. Okay. So let's see, we are here. Okay. So the way to send value into this transaction is just creating an object. So in this case, if you remember from send ETH, we have the send transaction and we have the to and the value, right? But in this case, since we are using the Sanford contract, the instance of the Sanford contract, we don't need the to, right? Because the to is already implied on the instance because we already instantiated with the address and everything. But maybe later, if we are doing like the Calldata stuff, we will need the to also. But in this case, we need the value. And the good thing is that we already have the value here because we know that this mean price, which is a big number, is the thing that we need to send. So this should be enough, I think.
And if you were writing this raw and you hadn't loaded the mint price and you typed in value equals quote 0.01, that's going to fail, right? You need to do an ethers.utils.parse ether. Yep, 0.0. There we go. Perfect. I just wanted to show that just so we know that like, oh, it's got to go to that 10 to the 18 big number. Okay, you can clear it out and go back to mint price, but that's a really good thing to show off there, just to like, if you were writing this, you would run into a problem right there with that mint price because it's coming in as a big number here. But if you just typed it in, you need to do the parse ether.
Yep. Okay, so let's go and see what happened. Oh,
here we go. GM.
Okay. Let's see if it works. 90%, I think that's going to work.
90% sure it's going to work? That is very optimistic. That's
95, 98 right now.
99, yeah. Once the transaction is sent, I mean, it's...
Mind. Okay,
yeah. Awesome.
So now
if we just mint?
Let's see, if we go to our address on Etherscan, okay.
16 seconds ago, called the mint method.
Yeah, nice. So we have.
Let's look at the call data of it real quick to get a peek at it, just to start talking about that call data.
Yes.
Yeah. If we look at the raw, like what just happened, we just sent a raw transaction to the address where the smart contract is, but there's some extra data in that field. There's this method ID. Look at this 0x1249C58B. What the heck is that? It's actually the hash of mint. Oh yeah, here we go. Can we do that online? Catchak 256 is what the hash function is.
Yeah. Let's see if we can do that.
Can we do like an online? Yeah, that's what we want. And if you put in mint, yep.
Yeah, it's actually like getting like the first 8 digits, which is like the first like 32 bits, right?
So this is our 6. Yeah. It's, what is it? 4 bytes. It's 4 bytes of data, right?
4 bytes.
We're getting, we're getting, this is what's called the function signature. So let's say mint takes in some address too. You would have mint and then it'd be parentheses and then there'd be an address in there and that would change the hash. So this is what's called the function selector, and it's just the hash of whatever the function is you're calling plus the types that are going in as arguments. And the smart contract is smart enough to know when there's a data field that matches this exactly, that means the person wants to call the mint function. And so we'll get in and we'll do more call data, but this is just like really hammering home the fact that everything is a transaction. It's not like you make some transactions to send some stuff to people, but when you want to go talk to a smart contract, there's a different way to do it. Everything is a transaction. Everything goes into the mempool and gets mined. Well, I guess there's MEV and stuff, but everything gets mined into a block. And that's how you interact with contracts. You're just interacting with the contract by making a transaction with a specific data field that lets the contract know that you want to call the mint function on it.
So can I do like a really quick test with the call data and see if
let's do it.
Works? Okay, so here we are using like the contract helper, right, from Ethers. But let's try to do like a raw transaction from Ethers, like using the call data. So we are going to remove all of this, and then we have the signer. So let's do this real quick. The mean price is going to be Ethers utils parse. No. And then the mint Calldata is going to be, let's copy that from here.
Yep. So we're going to just craft up a raw transaction that does the same exact thing, but without the contract interface.
So we are using right now the Rinkeby signer, and then the send transaction, the same thing that we use when we were sending ETH. But now we want to send it to the Sanford NFT address. The value is going to be the mint price, and the data is going to be the mint call data.
So what would happen if that data wasn't there? So if you just called send transaction with the contract and the value, what would happen?
I think it will send just
it
like
would try
money
to
the contract. It will try, right? But
and I don't know if the contract has a receive function, but the contract has to be, again, like explicitly set up to receive ETH. And if it's not, it will probably just fail. But without that data, you're just sending money to the contract. With that data field added in, you're sending money, but you want to call a function with that money that comes along with it. And you want to call the mint function on it. And sometimes there's arguments that go with that. And that goes in the data field also. But just the distinction there, that extra data field is really powerful. And when you're deploying a contract, there's no to address, and there's a data field that has the bytecode of the contract. Everything is a transaction. It's just packaged a little differently depending on if you're sending money or if you're deploying a contract or if you're talking to a contract.
Actually, that happened yesterday, right? Like we tried to send like some ETH, and the to field was like null, like undefined. So we deployed a contract, right?
But it was like an empty contract too. The data was also undefined.
So also like Austin was mentioning about arguments. So actually it will go here. Like I think it's like 32, I don't know, something like that. And then here it will be like the arguments at the end of the
we'll see it if we do if we do some DAI interface later, we'll be able to send and receive. We'll see it in a little while.
Okay. So let's try this. I mean, this should work, right? Day 2, and this is contract Calldata. Okay, let's see.
Wow, a raw transaction. We are really leveling up our scripting skills. Messing around with call
pretty
data.
Detailed.
Yeah, getting into it. So from the Etherscan point of view, this should look exactly like the last call. Like from the point of view of Etherscan, the transaction looks exactly the same. But for us creating the script where we had to package it up and use the, whoa, is it not showing up? What did we do?
No, I think, I don't know. I mean, it worked because it's
20 seconds ago. Okay, it's there. Yeah.
But maybe this is not. Oh, here you go.
There it is. Yeah, sometimes it takes Etherscan a while, especially on like testnets. It could take a bit. Yep.
So this is actually like the
exact
same
thing.
Right?
Yep. We send in value, we paid some gas, and we have this method ID that we want to call when we make that transaction. Dang, that is some handcrafted stuff. This is some bespoke transaction creating here. Very nice.
Yes, and also here you can add like some like gas prices, like the nonce. You can add like more stuff here. Like if you want to craft it even more, you can add like the gas prices, the nonce, and more stuff here.
For instance, like let's let's do it real quick. Let's go back to that. Let's figure out what our nonce is. Let's hard code our nonce and let's hard code our gas price. And then let's put that same transaction in at a low price and then a higher price. So it'll be nonce number 4 will be the next one, right? So we do nonce 4.
I think that would
and
be
then
like
we do
a regular
gas.
number.
What?
Like the nonce.
I think just leave it like that. Let's see what happens.
Okay.
If we have a problem, we have a problem. Like this is a good
Yeah.
exploration. It's a good rabbit hole
Yeah.
to go down. And then let's do gas price at just put like 1,000. So it's like super low, 1,000 way, right? Actually, it probably won't even let us into the mempool with 1,000 way. But let's see what happens. Let's just like YOLO that and see what it does. It probably will say that's insufficient gas. And hopefully like it doesn't we may get away with like minting it at 1,000. If this was on mainnet, this transaction would hang out in the mempool for a long time. See that? It's like 0.000001 Gwei. If we were using a fully set up network where the miners are picking the best gas prices. Okay, so hopefully this transaction doesn't go through. And so what we should do now is we want to speed up the transaction. Remember when we had MetaMask up and our transaction went in too slow, we were able to hit speed up. And what that's doing is resubmitting the same transaction with the same nonce, but a higher gas price. So we've kind of replicated that here. Hopefully, I think it is stuck. So now let's resubmit the same transaction. So you just Control C, kill that, right? You go to nonce, then just add some more zeros to that gas price, like probably 6 more zeros. Yeah, maybe 7. Let's just like really go for it. There we go. All right.
Okay.
So now with the same nonce, there's going to have the same exact transaction in the mempool. We're going to bring up another one, and you're going to see in the mempool, oh, this one has lower gas, same nonce. Throw this one out. Put this new one in there. It should get mined. What were you going to say? Sorry, I went off on that.
No, like the nonce is the important part, right? Like it needs to be the same nonce. If not, if it's number 5, it's going to be stuck forever because number 4 is never going to be completed.
Yep.
So let's see. Okay. Oh, 10 Gwei.
10 Gwei, right? That should work.
Yeah.
10 Gwei should be enough on
mine.
Yeah, it worked. All right. We proved to ourselves that gas and nonce worked, and we can speed up a transaction manually if we're creating it. Very cool.
Success. Nice.
So just a reminder here that this was what we were doing from the MetaMask interface just the other week as well, but it didn't allow us to actually change the nonce and like send another transaction.
Oh yeah.
So like it kept giving us errors, but now like with the code you can do everything.
Yeah.
So just
take that MetaMask.
Yeah.
We'll write our own transactions with blackjack.
Yeah. For some reason it didn't work. I don't know. Like you could like speed up from the MetaMask, but if you try to like submit the same transaction with a different nonce, it didn't work. I don't know why, but yeah.
Okay, so what do you guys think about Eda doing a little DAI interface now? Have we completed it? Have we completed your stuff so far, Carlos, or was there more to show there?
Oh, I think yeah.
Is that it? Yeah. Okay, so let's say you're a person at home now and you want to fork this and build something to talk to the DAI contract, either on mainnet or on Rinkeby. Oh, you're going to commit that? Now let's look real close here. Make sure there's no environment files, right?
And also going to create like sorry.
No, go ahead.
I was going to say that let's create like a quick and dirty README file, which is also always important, right?
Yeah.
You have to say like set up steps and say clone repo, then install dependencies with npm.
Man, good spelling on dependencies. I always have to, it takes me 3 or 4 tries on that one, and it's my first language.
And then what else? Oh, like copy .m example to .m, right? And fill the required data or keys. And now run the script of choice with node I don't know, like day whatever, and then script I think this is good enough, right? For now, at least maybe
Yep.
we can iterate on the README later, but
Yep.
I think this is
So triple check here. We don't have an env file that's getting added. When he does this get add all, it's very scary. Make sure when you do a get status, you don't have any files that have any private keys and it's just like, man, you got to be very, very careful about that. Yeah.
You can do this git diff cached, and then that will show like everything that you have on the staging, like the git staging, and it will show like all the, so you can take like a quick look, you know,
make sure there's no private keys. Yep,
yes.
Exactly. Yep, cool.
So here you have to be be careful about the .m file. This is the only file that you don't need to comment, right? And since we added here, it's not going to be committed. Okay, so I guess now I need to like create a new repo, right?
So yes, or if you could just push that up so Etta could pull it down and we could work. Okay, you tell me.
No, I need to create a repo, right? For
oh,
this.
I see. Okay, sure. Yeah.
So let's create, how should we name this?
Week two scripts?
Yeah.
Scripts.
Scripts. It's going to be public, right? For now, at least. Yeah.
Yep. Maybe throw an MIT license on there just in case. It doesn't matter.
Yeah.
It's already.
So
okay, cool.
Let's add this and okay, let's use main also.
So we switched to a main branch, is that right?
Yes.
Why not just have it on master? Why is the main?
Yeah, it's like a new notation, I think. Like people move from master to main just for like language stuff.
Okay.
So some music, please. Can you see this now?
Yeah, we do see a password. Yeah, be careful. Go put that somewhere else. Mute your thing. Yeah. This is scary. Blah, 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 blah.
And your kids have password.
It worked. Good work. I like this. This is a fun game to play. All right. So now any of us can pull that down. Could you shoot that repo to us in the chat and we'll put it in like the video notes too if someone happens to be watching this.
So what is the what is the README? Oh, okay. I think I didn't commit this. So it's like day 2 and README.
Nice.
So now let's push origin main. Okay, now here we go.
README. Cool.
Yep. Okay, so I'm going to paste this to you in the chat.
Got it.
Awesome.
Okay, so we're cloning that down.
We can do it like the opposite way, right? Like Eda can like clone the repo and start from scratch, which is similar that the same thing that people are going to do when they see our videos, right?
Yeah. Do you want me to like steal the screen and like do it together?
Yes.
Or?
Yes, please.
All yours.
Yeah.
All yours.
Let's do it.
Okay. Let's give it a try. Yeah. So here's the repo, Carlos, week 2. I'm just gonna get this. I'm pulling up my terminal here.
So our goal, let's set a goal here. We've got maybe like 20 or 30 minutes. Let's set a goal to have a script. Just like we were sending 10% of our ETH, let's have a goal set up where anytime the script runs, it sends 10% of its DAI to Sanford or something like that. Does that sound like a good enough challenge? So instead of sending ETH, we're going to be sending a stable coin DAI, which means we're going to be interacting with a smart contract that moves that token around, not sending it at the base of the protocol. I don't know what I'm thinking. We're not sending it as value. We're actually going to make a smart contract call.
Okay, so the first thing I guess is, we do need to do npm install, right? Like first let's install the dependencies.
So you did a clone, you did a git clone so far. Yep, then we cdn.
Only git clone.
And we npm install. I'm on it. Yeah. So fast. That Ethers.js script is really light. Yeah, Rick Moo really takes pride in that, I think.
Yeah.
Okay.
And one
what about our
.env
file? Oh, go ahead. No, you go.
Yeah, that was exactly what I was going to say. We don't have the .env file. with the secret keys. So that's like one thing which we need to add. And this example env is always super helpful. So I'm just going to do that. Right. Let's just add. Oops, this is going to add.
Oh, she's not following your instructions. She's making one straight up. the README says you copy the .env example file to .env. You're doing the exact same thing. No, it doesn't matter. That was a big JK.
Okay. I usually just like copy and like create my own from
you're doing it right. You're doing it right.
Stuff, yeah. So
and I'm gonna
do you have, I mean, not sure if you have the, because do we want to
key.
use like the sound for private key or what do you want to use for?
Let's create a new one, right? Okay, so no, this is a really good point. Like when you're building things, you're really, you want to just go grab a private key you already have created. This is awful OPSEC. Like don't do that. Generate for every new script, for every new thing, for every new place, for every new machine, generate a new mnemonic, generate a new address, and fund that address from an external source with just enough money to do what you need to do. So if that happens to leak in some stupid way, it's an isolated thing, not, oh man, Sanford just lost his NFT and all his money because we used his private key in here, right? So let's do some good OPSEC here and let's generate a new mnemonic and let's go ahead and fund it.
Yeah, like you can do that.
Just from the utils file, it's already here. So I'm just going to run this file to like generate and save that information, right?
Yep.
So maybe I could just like stop sharing my screen while we do that, or just
like, here I could do it over here. I could share the screen so you could do the same thing. I'll steal the screen and I'll have it up on my side and I'll run the same thing. But you do the same thing, but yours will be a little different. So what are we doing? We're getting into basically I need to generate a wallet, right? So I need to do something like
you can create like a new script, or you can even like call the utils file and comment the line of the.
So I need to bring in our utils and I need to bring in the, what is it? Create wallet. Oh man, why doesn't my thing? Yours has such good. So we want the generate wallet, right?
Yeah.
And then I'm going to call something like,
I think you just need to call that function, because that function is going to print everything on the. Yeah.
There we go. Okay. So I have a private key here and I have my address. So then I would take that private key and I would put it right here, right? And that's what Edda is doing right now. And then I would hide that. So save and get rid of that. And then do I need to put in an Infura ID there too?
Yes, I just pasted it into the chat if you want to use that.
Okay.
That's the one that
is that that's the very public scaffold ETH one, so it doesn't matter. Okay. And then I would get into here. Oh, whoops, where's my, oh, it's hidden. Oh, yeah, see, it's gone out of my editor. So I need to, let's see. I could just cat the .env file, right? And that will show it. Yep.
Yeah.
So if I wanted to edit that, I could, oh man, can I do this? Oh yeah, you like that?
Yeah.
You like that?
Oh,
there we go. You like that? $WQ because I know it. What?
Yeah.
Okay, so basically I created my, and now if I cat that env file, I've got my private key, I've got my Infura. Hopefully Edda has the same thing, but a different private key that is not okay to expose. I'm gonna totally trash that one right now, but I wanted to show those steps off just so you at home know exactly how to go through that.
Yeah, I did that in the same backend over here on my end.
Quietly,
so now, we have our .env file. And
awesome.
It would be funny if I had exposed that right now.
Right there, there it is.
Just open and that comes up. But no, so everything is just here, the file. I didn't do anything, just added like the .env part. So
cool.
yeah, now
and what's your address? Can we fund you? Can we send you some? What we need to know is the address of your wallet. But we could do that by, can we script that up real quick maybe?
Yeah, like you can create like a new script and import the utils and then get the signer. And then we can just print like signer get address or something like that.
Okay. So let's see.
Okay.
So what function would we be calling? We're looking at the utils right now. We need to kind of pick out one of these scripts to run, right?
The get signer.
Or should we even duplicate the send? Can we duplicate the send ETH script and create a new script called get address or something like that? Is that okay?
Yeah.
Okay.
Sure.
Yeah, get address maybe or something. Yeah. And then in here, we just want to instantiate that signer, the Rinkeby signer, and then something that you probably console log Rinkeby signer.address, right? Does it do that? And then we can delete everything else.
Yep.
Just so we have.
Okay, so we don't need like all this, right? Like,
No.
Yes.
we don't
I mean,
need
you could leave the
standard
balance
address.
just in case. Maybe leave the balance, but just say, here's my address and here's my balance, right? So everything on line 11 down can probably go.
Yep. Nice.
And let's do one more console log that does Rinkeby signer.address, I think. I can't remember exactly. Oh, yeah. Oh, yeah. All right, let's run it.
This is an
Ooh,
day
is that an
4.
await? Probably not. Ooh, nope. You don't want to CD into the day 2 directory because the env file isn't there. You want to run your script from wherever the env file is. Yep. So you'll do a node day 2 / get address. All caps when you spell a man name. Oh man. There we go. There we go. There we go. Come on. Give us a balance of 0 and
I think address is without the
it's not a function.
parentheses.
Sorry.
Yeah.
Nice.
Okay.
Yes. Okay. Can you copy paste that address to me and I'll send you some Rinkeby. And again, if you're doing this at home and you don't have a buddy with Rinkeby, there's tons of faucets. Hit one of us up in the DMs if you know us. What was that?
We could get one from the faucet right now or we're racing against time.
Yeah, plus I'll race you. I get my MetaMask is super slow, but I still bet I get to you before the faucet.
Just running again to print the balance.
Yeah. Okay. 0.5 ETH on the way.
So are we going to interact with the Rinkeby DAI contract, or are we going to use the mainnet one?
Ooh, shoot. Yeah, I was thinking mainnet DAI, but you're right. Maybe we should. Well, we haven't exposed our contract. I mean, this is technically we could talk to mainnet. We could do mainnet here, right? Like,
yeah, I mean,
we could send some mainnet DAI and actually do like a real transaction. That would help us like run into gas issues and weird stuff too, right? Oof, we just upped our target. So now our new goal is
Are we still racing against time?
Well, I mean, I got another call in 30 minutes. We got to get it done. Yeah. So awesome. I think we can do it. I think doing it on mainnet is a good test. So right now you've got that Rinkeby signer there, right? We need to do get signer true and it needs to be mainnet signer, right? So that's the first thing we can change here in our get address is to have a main. Yep.
Yeah. And maybe rename it to like mainnet signer.
Yeah.
Yeah.
Cool. Nice. And now the balance should be 0. Yep. But it's time for me to send you some real DAI, some real money. I'm going to put it on mainnet and do it. Let's go. And I'm going to wait 10 minutes for MetaMask to load my tokens. There we go.
So maybe because now we are checking the balance, but the balance is going to be 0 like all the time, right? I mean, I guess like we also need like some ETH, right? To be able to send
I'll send
DAI.
you some. Yep.
Yeah.
That's for the gas fees, right? Like to pay for just to make it clear.
Yeah, because if
let's actually not send the ETH at first, right? Let's just say, let's send the DAI in. We do this all the time, right? And then we hit send and we're like, why isn't it sending? Oh yeah, we don't have money for gas. Let's just remember we need to send some ETH in, but let's get that error. Okay, so you should have some mainnet DAI. Oh man, I think I just paid $8 to send you $10 worth of DAI.
Oh no,
it's not. It hasn't gotten mined yet. Ooh, I actually, yeah. Okay, hit up and enter. Let's see if we have some mainnet value on this address. Oh
But
no,
does
this
it-
is your balance. This is your
Yeah.
ETH balance,
Yeah,
right?
yeah.
Okay.
Yeah.
Okay. So I might, yeah. Let's just send some ETH
We could
just
check
to,
like on
yeah, let's just
Etherscan,
send it
right?
in.
We could check from
Oh, I
the
see.
code as
Put the
well our
address
DAI
in,
balance.
and then you could see, yeah, it's got $10 worth
Yeah.
of DAI. Okay, cool. So I'm sending to the right place at least. I'll send you some ETH just so you have it though. I feel like we're going to be stressed for time here in a little bit. So what we need to do is we need to interact with the DAI contract. Let's start by just getting our balance in DAI, right? So we
Yeah.
need to, is there a contract read?
The
Do you have
ABI,
some
right?
examples?
Like we need to
Yeah.
we need to get the ABI for the DAI contract, right?
Yeah.
So I think Eda, if you click into DAI on Etherscan, if you click in your balance there, you can check the contract there and go to the contract tab and then just like get the ABI there.
Yeah.
Perfect.
Super. So just like copy the API. Going back here, just gonna create a new file. Let's call it DAI API.
Yeah.
I need that
What is it, like
automatic
export?
formatting as well.
Yeah,
Yeah, if you want to copy like
it
the
doesn't
sum
matter.
for NFT,
Yeah.
just have to declare a variable and export it.
You need to export it still. So you want to click
Mhm.
on Sanford NFT ABI and copy the stuff right at the beginning. Yeah, there we go. That part. Yep. And then export
And the
it.
end as well, just to
Yeah,
make sure
yeah,
like
yeah.
that we export at the end. But I'll do this part.
I think you don't. Yeah, that one. Yeah.
Yeah, she got it.
I think we also need this part now.
Weird copy paste grabbing the semicolon and the square brace as part of the copy. Oh, it doesn't have it. Nice.
Yeah, because I always like miss or yeah, this is like you shouldn't usually like copy paste your API, I guess, like this, like use an indexer probably, but just for reading from the contract in this case.
Okay, so
And
we
yeah.
have the ABI loaded into our script. So now
Yes,
we've created our ABI. We need to load it into the script.
I'm just gonna steal
Like
from
maybe you
here.
can just
There we
like
go.
copy this
Yep,
this file,
I
right?
would be
Maybe
copying
copy
this.
the contract read and you can
Ah.
say like contract DAI or something.
Yep.
Nice.
We might use
Yeah,
Sanford's
we
address
need the
eventually.
DAI transferred,
Yeah.
but this is the smart contract
Oh, yeah.
address, right?
Yeah,
So
you're
we
right. We
need
need the
the
DAI address.
Yep.
Yep. Yep.
DAI address. So just, I guess this is the
No, it's
creative
right
one
top
now.
left. It's that. No, it's the 068. It's
Ah,
that one right there,
okay.
right? Yeah. And there's $500,000 worth of tokens locked in the DAI contract because there's not a withdraw function in the DAI contract, and people send tokens directly to the contract on accident. There we go.
We had the Rinkybait over here as well because it wasn't changed since we want to talk directly to Mainnet, just making that modification. And I think
9
this
and
looks
10
good.
still. Yep. We need to do Sanford
Well, mint
NFT
price,
address.
no, this is, we can just blow this. Oh, get that, right?
Yeah, on line 9 and 10, you still have the Sanford address and
sorry.
ABI coming in. We need to put the DAI address and DAI ABI. There we go. So now and probably rename Sanford contract to DAI contract. There we go. So now we have our connection to the DAI stablecoin contract. And it wouldn't be mint price. We want to probably get our balance or something, right?
I think it's balance off, right? That is like
Yeah,
the
I think
function
so.
that we want
And you
to
pass
call.
in an address. Yep.
Yes. And I think
Something like this.
I think capital O. I think it's camel case with no underscore.
Yes.
Yeah, I think it's that. And then you need to pass in what, our address, right?
I'm
The
gonna get our address.
94C. It's down below there. It's in your console, I think.
Yeah.
It's that right there, right?
Yeah, let's just make it better.
Maybe call it like my address or
Yeah.
local guy address. I don't know. Just to be a little more explicit about our variables. There we go.
Yeah. This is not mint price, right? This is
Right.
how
That
much
would be
DAI we
your
have.
DAI balance.
Balance.
Yeah.
Nice.
All right. We're getting close here.
Yep.
Yeah, this is, I think it's going to require some formatting. I'm not exactly sure what kind of formatting we will need, but we could just print the DAI balance.
Yep. I would just throw it right into that format ether. I bet it's going to come
Yeah.
back with that.
Yeah, I
Yep.
think so.
Yep. All right, let's run it, see what happens.
Yeah.
So we need to node contract underscore DAI. And this should go out to the mainnet DAI contract and it should check our address. Ooh.
We could check from here why it's right. Like, I think we have the wrong
Do we need to
name.
do dot methods dot balance of or something weird like that? Like why did that not work?
Balance of is
Oh,
not
you could also
effective.
search
Do I have
balance
it?
of in the ABI. The file that you have that's DAI ABI in the top right. Yeah, search for balance of in there. Yeah, it's there. Weird.
Hmm.
And it takes an input address.
Yeah.
Okay, what are we doing wrong here? Let's go back to that script. What the heck? It's saying that
Can
balance
you
of is
can
not
you
a function.
print
Let's
your
console log.
the ABI, the console log? Like, can you console log the ABI just in
Oh,
case?
is
maybe-
she?
Yeah.
Yeah, no, she is. Yeah, I would
Okay, I'm
console
just
log.
gonna like fly these over because it's a bit complicated with them. But let's console log. The what
Yeah.
do you want to console log? The DAI ABI. First.
Yes.
It's there. Yeah.
Mhm.
Okay.
So we get the DAI ABI, DAI contract. Do I have like?
Maybe console log the DAI contract.
Yeah,
and let's
but
make
I'm
sure.
reading from the DAI address, right? I should
Oh.
read
Oh,
from the
there we
DAI
go. It needs to be DAI
Yeah.
contract, not balance of. There we
Yeah,
go.
good catch. Good catch. Yeah.
All right.
Nice.
Yeah,
You
DAI
have
balance.
$10 worth of DAI. All right.
Yeah.
So
we're
now we want to
directly reading
duplicate
from the
that.
contract.
Yeah, so that's contract. Okay, let's just keep editing this same script. So
Yes.
we're able
Yeah.
to read our address. Now the goal is we want to send some DAI to Stanford, right? So we're going to need to call
Transfer.
dot transfer, I think, right?
Yeah. Yes.
And you could look
Okay.
that up by looking at the code or looking at the ABI. Let's just try it and see what happens, though. It's just mainnet.
So the thing is that we are going to need the signer. That on line 11,
Oh
we
yeah.
are
yeah.
using the provider. So instead of
Yep.
on line 6, we will need to get signer.
So instead of just saying mainnet provider, we want to say mainnet signer, and we want to do
Yes.
get signer true. And we
Yeah.
can trash the mainnet provider and just use that. I mean, maybe use that.
Yeah,
Maybe keep
we
it
could,
there
like-
because we show that we're using the provider just to get the balance, right? Oh no, then there's like, okay, this is interesting. So if we do it this way, we can have basically a DAI contract that's for reading and a DAI contract that's for writing, and it'll go through different providers depending on how you're doing that. And you do that a lot with your app. You'll see that in Scaffold ETH in week 3, we actually have read contracts and write contracts. So maybe this we could leave it like this. So let's have the DAI. Let's recreate the DAI contract from line 9. Let's copy and paste that whole thing. And let's do DAI contract write and send in the signer. So pretty interesting here, but yeah, go ahead.
Yeah, I was just gonna say, like, this is because of when we want to resolve the ENS, right? We read from like mainnet generally. So I think that's, and then with Scaffold ETH, right? Like you make the transactions like write actions to incubate, but read from mainnet. So
Exactly.
I
And
think we
reads
ran
can be
into that problem
faster
yesterday.
too. You could have a read provider that's just talking to, I don't know, Infura or something like that, but then your write provider may need to go through MetaMask or some other slower thing. And I think MetaMask is slow because Infura is slow, but let's say you have a read from Alchemy and a write through MetaMask to Infura or something like that. So your app could actually read faster than it can write. So it's nice to have those two separated. Okay, so let's see, mainnet signer. All right, so now we want to do DAI contract write, right? We want to be talking to the write version of the DAI contract dot transfer.
The
Ooh,
dye transfer?
it can't
Or
be
no?
dye transfer. No.
I think
No, it's transfer, right? I
Oh.
just like copy on the Telegram channel,
Yeah.
like the ABI part for the transfer function.
Okay. Yep. So it's
it-
maybe we
transfer.
can give
takes-
another address, right?
You
Let's
give it an
another
address and an
too.
amount. Yep. Let's put in Sanford's address if we don't have that already. Oh, we don't. Yeah, we need to get a new address. Yep.
Just gonna call it send to address.
What's Sanford's address? Could you paste that into chat?
Or maybe we
Carlos?
can query from the mainnet provider, right? We can do like a reverse.
Oh, like let's look up his address. Let's look up
Yes.
his. Yeah.
We're
yeah,
making
Let's
it
do
harder
mainnet.
every
Yes.
step.
So is it lookup address? Is that the name? So
It's
it would
resolve.
be
Is resolve name, right? Resolve, no resolve.
resolve name. Is that what it is? Let's
Yeah.
do it. Let's do it.
I think we also have it in another function, but we can just like do it here.
Like
Yeah.
on the send eth is there. If you want to copy and paste on the send eth script, we have there. Yeah,
Yep,
like line
there it
11.
is right there. Yep.
Yeah.
Okay, I'm gonna put it here.
And it is good that we save like the main
Yeah,
provider,
let's call it
because we can
Stanford
do
address
this stuff now. Yeah.
And this is
So we're
mainnet
just going to
provider.
our, yep, that's just our read provider, but it's fine.
Yeah.
That should work. Yep.
Yeah.
So now
And
Sanford's
it's good
address should
actually
be
we
set.
went through this. This was
Should we
the-
maybe just
the
console
note.
log Sanford's address and make sure it's set before we start writing our write? Should we just do like a console log of like sending die to Stanford's address to make sure it looks good?
Yeah.
There we go. Let's run that just to make sure that address is there and it does the resolving correctly. I mean, you could show your die balance too. It's not a big deal. Give us an address. There we go.
Nice.
Okay,
This is taking shape now. Yeah.
Yes.
almost
And you
have
can
that.
check
exactly.
this on Etherscan as well, right? Just to like verify.
Yep, there he is. And how much die does he have? 36. He has $36 of die. So we're going to send him a little bit more, right?
Yeah.
Okay. Let's not even send him. Let's just send him a hard coded amount. I was talking about 10%, but that doesn't make sense. Let's just send him $5, right? Okay, so now we're ready for line 31. The main event.
This is transfer, and it will take in. I'm just looking at the front.
It takes
Yeah,
in an
we will-
address and an amount. So it takes
Like
in the
Sanford.
second argument is a uint 256. And right here, let's say we wanted to just send 5. If you typed in the number 5, that would be sending 5 way. So what you want to do is send 5 ether. So the way to do that is to use parse ether, right? So we'll need ethers, utils, parse ether, and then 5 in quotes. And that should
Yeah.
send $5.
Yeah. Like even we are not sending eth, we use the util parse ethers to convert it to the like the format.
That's a good point. Yeah,
Yeah.
it says parse ether. It's not actually ether. It's just doing the times 10 to the 18 math. And I think you want to have quotes around it too. It doesn't like numbers either.
Sorry,
Yep.
I wasn't sure. Okay,
Okay. I
I
mean,
think this should work.
And then maybe we can say like transaction sent, and then do this die transfer
await
dot
stuff.
wait.
Yeah. yeah.
So you can
You
just
could
copy
grab
from
that
the,
from the send
yeah.
eth file too, probably.
Yeah.
Yeah.
Yeah, like the
Yeah,
line
the
20.
20 and
yeah,
24,
yes,
yeah.
Yes.
There we go. So it'd be die transfer dot hash. Nice. Nice. Okay. So what about mainnet gas? Do we have ETH in this account? What is the account address? Should we just double check that we have enough gas? Yeah, let's go to my address on Etherscan and just look. I think I sent some gas in. I can't even remember. It was like 10 minutes
Yeah.
ago. Okay, cool.
Yes.
We have
So I sent in some
$27.
ETH. Yeah, so you have $27 worth of ETH and you have $10 worth of DAI. And we're going to try to send 5 of those dollars of DAI to Sanford. And if we wanted to just send ETH, we'd just make a transaction with value. But since we have to send DAI is a token that's its own contract. So we're going to have to go to the contract and tell it to transfer some of our DAI. But I think it looks good. Should we fire it off and see what happens? Should we set the gas manually? What's going to happen if we don't set the gas price on mainnet? Maybe I think it'll price it for us. But technically we could set our nonce, or we could set our gas price here if we wanted to be more surgical with it. Ooh, 69 Gwei right now. It's a little hot. Let's fire it off and see if our $27 is enough to send here. Any last thoughts before we try to execute this mainnet transaction?
I think all good. Just printed the DAI balance over here as well to see the new balance without like going to Etherscan.
Nice.
But yeah, Carlos, sorry, I didn't mean to interrupt.
No, I was going to say like 90% is I think it's going to work.
He's 90% confident.
Yes.
Optimistic.
Never.
I trust Eda. I trust Eda. I think
All
it's
right,
going to
let's
work.
fire it off.
No,
Let's see what
don't.
happens. Oh no.
Okay.
No, it's already been declared because
No, but
Seconds, like new DAI balance.
27.
You could change it
There we go.
as well. Like instead
Okay,
of
this doesn't count. This doesn't count.
That doesn't
Still
count.
like
Doesn't count.
95.
Okay.
that was the last minute when you were not looking. I guess I was just doing that.
Okay,
All
98.
right, so our DAI balance
99.
is 10.
99%.
We're sending DAI.
Oh
Transaction
God.
is out there. Can we go look at that on Etherscan?
Yeah. Just gonna do that.
There it goes. It's going to take less than 45 seconds, meaning we paid the right amount of gas. If we scroll down, let's see what gas it selected. Oh. So it decided to do
156.
Oh, that was an expensive transaction. We probably should have coded up the gas because it only needs to be like 70 something right now to get through.
But it actually
wait.
adjusted. I think that was like
Oh, that was with
right?
the
Because
base.
it was
Yeah, the base fee.
through.
Yeah. Yep.
Yeah.
Okay, can we open up the full transaction? Can we click to see more there? Actually, let's see this first. Yeah.
Nice.
The transaction was sent and our new balance is 5. And if we go look at Sanford should have some DAI now, right? If we went to Sanford's address on Etherscan, but I want to keep that transaction around because I want to go look at the call data. And we did it. It worked. And yeah, let's check and see, what did he have, 36 before or something like that? Now he has 41 DAI, so it works,
Nice.
right? We sent some stable coins by writing a script that talks to a contract that tells the contract to send some of our DAI. Can we go look at the call data real quick? Oh, go ahead.
Yeah, just a note, like you don't see it here, right? You have to look at the ERC20s for transfer because we're transferring the DAI token. Yeah, I'm not sure which ones get seen here actually. Like you can go to all of these, but on the ERC20 token, you can see that it just came in, right? $5 worth of DAI.
Yep. Yeah. If Sanford was looking at his transactions and you said, I just sent you $5, and he's like, it's not here. It's not here. Yeah, it's over in that internal or the ERC20 tokens. Yep. Awesome. All right. I want to see the call data. So this call data had arguments. So there we go. This is what I wanted to show here. So we called transfer with some destination and dang it, maker DAO people. So yeah, the address is the to address, and then the WAD is the amount, right? It's a UNT256 amount that we sit in, and we can see that the address is, we see the method ID, which is if we were to get the hash of transfer with address, comma, UNT256 parenthesis, that's the function signature. That would be that A9059CBB. So the method ID is that specific transfer function with that signature. And then argument 0 is the address, and we can see it there. And argument 1 is the $5 we sent, be 5 times 10 to the 18 is that big number there in hex. And that's what the call data looks like. So again, to send DAI, it's just a transaction, but the transaction looks like this. There's not a value that goes along with it. There's this call data with the selector of the transfer function and the argument saying, go to this person and this amount and send this amount. So we did it. Any questions there? Are we covering it correctly? Hopefully you at home followed most of this. It was a little wild. I think we did it though.
Yeah.
I think that was
Awesome.
a good one. Yeah, we covered a lot of stuff in this episode.
Awesome.
I'm going to call it episode.
Episode. Yeah, we did it. All right. So hopefully you at home are getting your scripting going. We'll commit some of this up to you tomorrow. Next day we'll get into more like scripting and more Calldata stuff and more automation stuff. Any thoughts? Any closing thoughts, Carlos and Etta? I think we did it.
No, I think we
Awesome.
did like a lot of stuff, you know.
Yes.
Yeah.
You at home should understand what providers are. You should understand what signers are. You should understand how to create a wallet and load it from an env file. You should understand like imports and modules and some node stuff that we went through, right? Format Ether and parse Ether. Hopefully you're understanding how to send ETH versus how to interact with a contract and how that's different. Even when we interact with the contract, if we send it a provider, it's sort of like a read only. But if we interact with a contract with a signer, then we can write to it by signing transactions. I think we did it. I think we got it. Like that was, and we even did some ENS stuff. So we're actually reading from the ENS contract what their address is, and then we're writing to the DAI contract to send to that address. So we did lots of good contract interaction too. All right. Happy Thursday. Thanks for being here.
Awesome.
Good work, guys.
Thank you. Thanks,
care.
everyone.
Thank you.